Okay, so now that we've got our identities, I erased them, but you have them written down now. Let's apply them to figure out an exact value for cosine of an angle, sine of an angle, and tangent of an angle that we haven't been able to find before. We're going to find exact expressions for cosine of 105, sine of 105, and tangent 105. Okay. So, first, cosine of 105 degrees. Well, I need to break this angle into two angles that I know the cosine and sine of. Well, what two angles could 105 be? If I were to add up to 105, what would I get? Well, I think cosine of 60 and 45 together, if I add these angles, I get 105, right? 60 plus 45 is 105 degrees. So I know cosine of 60 and I know cosine of 45, so I'm going to be able to find out what cosine of 105 is by using my angle sum identity. So cosine of a sum is equal to cosine of each angle minus sine of each angle. Okay, and now I just replace cosine of 60, cosine of 45, sine of 60, and sine of 45 with what I know them to be. Cosine of a 60-degree angle is, if I recall, 1/2. This one is root 2 over 2. Root 2 over 2. And root 2 over 2. And this one is root 3 over 2. And this is root 2 over 2. So what do we end up getting? 1 times root 2 over 4 minus root 3 times root 2, which is root 6, over 4, which equals root 2 minus root 6 over 4. There's an exact expression for the cosine of 105. The calculator to check the answer, and I encourage you to do that. Figure out what this number is approximately. Also type cosine of 105 in and compare your results. They should equal. Okay, so now let's find the sine of 105 degrees. Two ways to go about it, but we'll just use the angle sum since that's fresh in our minds. I can break this into a 60-degree and a 40-degree angle. So we get sine of 60 plus 45, which is equal to, using the angle sum identity for sine, it's sine of 60 cosine of 45 plus cosine of 60 sine of 45. Sine of the first angle, cosine of the second, plus cosine of the first angle, sine of the second. Okay, what do we get? Sine of 60 is root 3 over 2. Cosine of 45 is root 2 over 2. Cosine of 60 is 1/2. And sine of 45 is root 2 over 2. So overall, that's root 6 over 4 plus root 2 over 4, which is just root 6 plus root 2. And that's the answer for the sine. Okay. So we know what cosine is, we know what sine is, so we can find out what the tangent is. Tangent of 105. Now I have my choice for finding the tangent of 105. I can either use sine over cosine and divide these two expressions and simplify, or I can use the angle sum identity as I did before for sine and cosine to figure out what the tangent is. I'm going to do it using these expressions, and you can do it using the identity on your homework today, tomorrow, if you would like. So using these expressions, this is equal to sine of 105 divided by cosine of 105, which now we both know root 2 plus root 6 over 4 is sine, and root 2 minus root 6 over 4 is cosine. Okay, so now we flip this fraction and multiply plus root 6 over 4 times 4 over root 2 minus root 6. 4's cancel. That gives me root 2 plus root 6 over root 2 minus root 6. Now I have to rationalize this, and it's a little bit tricky to figure out what to multiply by to rationalize. Well, if you recall, a squared minus b squared, I want to square both of these. So I need to multiply this by a plus b. So we multiply by root 2 plus root 6 over root 2 plus root 6. This is 1. That takes us up. 2, root 2 times root 2, which is 4, root 2 times root 6, 12, root 6 times root 2, another root 12, root 6 and root 6, 6, and then these guys, root 2 and root 2 is 4, whoops, oh, wait. Sorry, that's root 4, this is 2. Root 2 and root 2, that's 2. Okay. Minus root 2 root 6, or minus root 6 root 2, and plus root 2 root 6 cancel, and that leaves me with minus 6 over here. Okay, let's clean this up and simplify it as much as we can. We get 8 plus 2 root 12 over 4, negative 4. And then I need do a little bit more work here. 2 root 12 is actually equal to is 8 plus 4 root 3 over negative 4, which is negative 2 minus root 3. That's my answer for the tangent of 105 degrees. And again, I can use a calculator to double check that this is actually what the tangent equals. And that's how you find exact expressions for these angles that we haven't been able to find.